Hello and welcome to T1 Day 22 of Honors Precalculus. We're going to continue talking about the unit circle. Woohoo! So we're going to find the exact point on the unit circle that corresponds with an angle that measures 120 degrees. So remember, we go counterclockwise and we start with our initial ray here, and the terminal ray is 120 degrees. We know it's 90 degrees to there, so it's going to be 30 degrees more. So you end up with something like this. Well, maybe a little bit less. So like around there. So we know that this right here will be 120 degrees. Well, if that's true, then we know that this right here is 60 degrees. So when you're asking for this exact point right there, you need to know that that's the 30, 60, 90 degree triangle. So that point right there will be cosine of 120 degrees, comma, sine of 120 degrees, and this is just a value you need to know. You need to know what that point is when it's a unit circle, which means that this radius is 1. As you see, it's right there. So you just need to know that cosine of 120 degrees is going to be negative a half, because this distance going backwards here is negative a half, and then comma, the height here, this is a value you have to know. This is going to be root 3 over 2. So it's that root 3 over 2. Now when you do negative 240, the negative there means you go in the opposite direction. So you're going to go 240 degrees this way. Well, if you go 240 degrees clockwise, you actually end up at the same angle measure right there. This is called coterminal angles. They end in the same place, coterminal angles. So you end up with the same values, negative 1/2, root 3 over 2. Now what about 3 pi over 4? 3 pi over 4 is in radians because it has pi in it. It's definitely in radians. So what is that going to be? Well, we know that pi is all the way around, it's 180 degrees. So 3/4 of that is going to be right, I'll go to red here. It's going to go off like this. And that's going to be a 45 degree triangle right there, 45, 45, 90. So if that's the 45, 45, 90, you know it's going to be negative. It's going to be, more specifically, cosine of pi, 3 pi over 4, comma, sine of 3 pi over 4. And you just need to know that that's negative root 2 over 2, comma, root 2 over 2, that point. So what do you end up with? Negative root 2 over 2 and root 2 over 2. Because you got to go backwards for the x value and up for the y value. And these are exact values. They're not written in decimals. But what happens if we have a circle of radius r instead? So instead of having a radius of 1, let's say we had a circle of radius r. Well, if this was 1, and if this side length was 1 right there, we know that this side length right here is cosine of theta, and this is sine of theta, because that would be the unit triangle. But let's say it was r instead, and this was x and this was y. How would you write those things? Well, you know that x over, well, you know that sine of theta for here, sine is opposite over hypotenuse. Opposite over hypotenuse is going to opposite over hypotenuse, y over r. And you know that cosine of theta, adjacent over hypotenuse, x over r. So what does that mean? Well, it means if you multiply both sides by r here, you know that y is going to be equal to r sine theta, and x is equal to r cosine theta. So all that happens is an r gets put out front. So this point right here, when this right here is r, that point right there is just going to be r cosine theta, comma, r sine theta. And it worked before because r was 1. R was 1 before in the unit circle. So this says the radius is 500, and find the point of intersection of a circle of radius 500 that corresponds with 405 degrees. Well, it's 360 degrees all the way around. So 405 minus 360 is equal to 45. So this just goes another 45 degrees right here. So it's telling us that this distance right here is 500. So this angle is 45 degrees. So from above, we just know that this coordinate right here is going to be r. So 500 cosine 45 degrees, and then it's 500 sine of 45 degrees. And you need to know that both of these right here are root 2 over 2. So the final answer here would be 500 root 2 over 2 comma 500 root 2 over 2. I like the parentheses right like that. I like that. You could simplify it and make, you could simplify it a little bit and make it 250 root 2 comma 250 root 2. The 2's cancel. So now we're back to Ferris wheels, and it's 500 feet tall, and it takes 20 minutes for 2 full revolutions. So 2 revolutions equals 20 minutes. So that would mean that 1 revolution is equal to 10 minutes. At time equals 0, you're at the 6 o'clock, so you're on the ground. Done that before. So if we just say that this is 500 feet right here, this is h of t in feet. And let's say that this right here is 20 minutes right here, and that's t in time. We know it's going to start here, and then in the middle here, it'll come back at 10 minutes because it takes 1 revolution every 10 minutes. So it's going to be up here, it's going to be up here, and then we know all these midline crossings. Remember, I like to use the highlighter. Curves this way, curves that way, curves this way, curves up, curves down, and there we go. Nice. So we drew the graph. How high off the ground will be at 7.5? Well, this is 5, this is 7.5, so you're actually going to be on the midline, so that's just going to be 250, so 250 feet. How high off the ground will be after 4 minutes? 4 minutes is a little tricky because you have to estimate it, because you know this is 2.5, so you know 4 minutes is going to be like right about here, so you could say it's about you know, if you had to estimate this, this is going to be 250, this is going to be 400, so maybe like 425, around 425 feet. Well, not degrees, feet. That's an estimate. You don't know exactly. So now let's do some exact measuring. So we're back on Ferris wheels. FW, nice. 150 feet. So you got a 150 foot Ferris wheel right here. It's 150 feet. Nice. And it takes 8 minutes for 1 full rotation. So 1 revolution is 8 minutes. It's right there. 8 minutes for 1 full revolution. That's this right here. At time equals 0, you're at the 6 o'clock. So you're right here. So time equals 0. So how high off the ground will we be at 6.5 minutes? So 6.5 minutes, so it goes all the way around in 8 minutes right here. So you can say, you know, how much of a revolution do you go in 6.5 minutes? Well, we don't know, but we know 1 revolution is 8 minutes. It's how much of a revolution is 6.5 minutes? How are we going to go about doing that? Well, we can cross multiply here. We know that this times 8 minutes is going to equal, I'm just cross multiplying here, 1 revolution in times 6.5 minutes. So what do we end up with here? We end up with a little bit more. Revolution equals 1 rev times 6.5 minutes over 8 minutes. Those cancel, that cancels. So we're just going to get a number here. So question mark is going to equal 6.5 over 8, which equals 0.8125. So that's how much of the full rotation, that's how much of the full rotation has happened right there. So now we can use that information to figure out how many degrees we've gone here. So what that means is this is how much of 1 revolution we've gotten there. So how many degrees is that? Well, that would be 0.8125 times, let's do degrees, times 360. So if we do that, you end up with 292.5 degrees. So what that means is from here, it's gone 292, so 180 degrees there. So it's going to be about here. So if that's 180 degrees, it's gone another, how much further has it gone right there? How much further has it gone? Oh, sorry, 180. And then it'll be 270 to here. Got to go a little further. I'm sorry. So that's 270, but it's 292. So it's 270 all the way to here. So how much further is it? It is 22.5 degrees right there. 22.5 degrees. So this rotation has gone that 81.5% to there, and it's all the way to there, right there. So when we do this, what angle are we talking about here? This 22.5 degrees here. So we have a radius of, how high is it? The radius here is going to be 75 degrees right here. We need to know what this angle is right here. What is that angle right there, the green? Because all of our trig functions start with this initial ray right there. Well, this point is what we're looking at, right? We're trying to find this point right here. What is that point right there? Well, we know it's going to be r cosine theta, r sine theta, where this is the height, because that's the y coordinate. So we're looking at 75 sine of 202.5 degrees. And we get that because this distance right here is 202.5, because that's going to be 292.5 minus the 90 degrees. You're subtracting this. So when you do that out on your calculator, you end up with y is equal to you get a negative 28.701. That's the distance from here to here. That's the distance from there to there, but that's going to be starting at a height of, halfway up is 75, not degrees, 75 feet. So how high up is the person? How high the person is right here. That's this. So that's going to be the midline minus this. So it's going to be 75 minus 28.701. So the person will be at a height of 46.299 feet. We will definitely practice this in class. This is pretty complicated. So similarly, we have a 100-foot Ferris wheel this time, 100-foot diameter, and it takes 6 minutes. So 1 revolution is equal to 6 minutes for 1 full revolution. At time equals 0, you're at the 3 o'clock. So this is right here, time equals 0. So that's our normal initial ray. How high off the ground will be after 5 minutes? So where will you be after 5 minutes? Well, how much of the circle have you done then? You've done 5/6 of the circle. If one circle is 5 minutes, we've now done in 5 minutes 5/6 of the entire circle. So what is that angle going to be? Well, you can multiply the 5/6 times 360 right there, and you end up going almost all the way around like this. So when you do that, you end up with 300 degrees. So if that's 300 degrees, this right here is negative 60 degrees. So one way to look at this is to do the radius right here. Here's the radius, and it's asking how high off the ground will we be at 5 minutes. So if we use this, we're going to get the formula, we're going to get that coordinate right there, which is r cosine theta, r sine theta. So when we do that, you're going to end up with r is 50, so 50 times sine of 300 degrees, and that's going to give you negative 43.301. Remember, that's giving you this distance right here, the distance down. This is the x-axis when we do these calculations. So how high is this? Well, it's 100 feet high total. This radius is 50, so this distance is 50. So what's going to happen is you're going to have 50 minus 43.301. So the person is only 6.699 feet off the ground.